All right, so the last part of this worksheet is a test review on the transformations and matching it to our parent function. So when I'm looking at each of these transformations, I'm looking at what happened to each of these equations from its parent function. So this linear equation parent function is when I have a line that goes through the origin and a slope of 1. This quadratic parent function is when I have a quadratic sitting right on the axis. Now this square root parent function is where I start off at the origin. And this absolute value parent function is where I have this kind of idea. So I have to picture the line starting at the origin and then how has it changed since then. All right, so let's go upstairs, up top and look at each of these different equations. So this plus 4 means that my graph was moved to the left 4. So when I look here, this one has not been moved to the left 4. Not for here. This has been moved to the left 1, but here, 1, 2, 3, 4, this must be f of x plus 4. So this one matches up with A. All right, let's take a look at B. I have an equation that is half, meaning that I have a compression, so it's going to be a flatter graph, and up 1. This one's definitely not up 1. This one's not up 1. So if I look here, does this make sense? It went up 1. And now I can look at that as the slope. Rise 1, run 2, rise 1, run 2. Yep, this one's going to be B, which is y is equal to 1/2, making it flatter, like the slope, and bumping it up 1. All right, so here we have 2 left, which was the graph that had a vertical shift down 4. I think we all think it's this one. So f of x minus 4. And for D, we have this, which means it's a reflection. It's went to the left 1 and up 5. So 4 matches up with D. That looks good to me. All right, so now we're really reviewing, going back to some of our function characteristics from Unit 1. All right, is it continuous? Can I draw it on my whole pencil without picking it up? Not with this hole in it. So we're going to say no. What is our domain? So all of my x values start at -infinity, and they get up to 1, and then they stop, and then they continue on. They hop over a value of 1. Now my range, when I look up, down, this hole doesn't matter because this y value is covering it. So my range is going to be from -infinity to +infinity. Where is my f graph increasing? So as I think about that ant crawling up my graph from a value of -2 all the way up to a value of 1, the ant is climbing a hill. Where is it decreasing? From -infinity all the way to -2. Now you know it's been increasing after that, but then what happens when it reaches a value of 1 and on to infinity? Where is it constant? None. It never is constant. I'm either increasing or decreasing. As x approaches -infinity, as my x's get smaller, what happens to my y's? They get bigger. As x approaches +infinity, what happens to my y's? They are getting smaller. Our local minimums and maximums. So here's going to be a maximum, but I'm not quite there yet. So that's an interesting one because it doesn't quite happen. So we're going to go ahead and say none. The local minimums, we'll go ahead and say at -2. That smallest value is -2. That x is equal to -2. All right. Make sure you study and review for the test. I want you to do well.